Hey there, Josh with you, and I want to talk about what a foci is and why they're important to ellipses and what they mean. So let's start with a little bit of a review on an equation of an ellipse. Okay, so here I have written down the equation of an ellipse. So what we have here is x minus 8 squared over a squared plus y minus k squared over b squared is all equal to 1. So just as a review, we have x minus h. So if we, where our point is for the center, because this top part here is actually going to be, this big top part here is what our center would be. So the minus h is going to be the x point on here. So let's say it was 3. So let's say this is 3. This is actually going to be negative 3 then. So we go back 3. And then we have k, the negated of k. So let's say we have to have a negative 2. Negative 2 with another negative is actually going to be positive 2. So it's going to be right up here, over here on this graph here. So, and now we have a squared and b squared. And let's just assume for a moment that a is bigger than b. So I'm going to write that a is bigger than b. And that's just so that this equation is written correctly, because otherwise it would need to be flipped. If b was bigger than a, then x would need to be over here, because whatever it's stretched more needs to be first. So if y was stretched more than x, meaning that it went more like this instead of like this, then y would need to be first. Okay. So, but we're going to assume that a is bigger than b, so that we get a more stretched out like this. So let's say a squared was 9, then we know that it would be 3 over, and if b squared was 4, then we know it would be 2 up on each direction, which would make up the axis, the major and the minor axes. And if none of that makes sense to you, then you should probably go back and review circles and ellipses, and I have a video on it, or use Khan Academy, which is a great tool. Okay, so now let's talk about the foci. The foci are going to be 2 points along the major axis of an ellipse. So in this case, because it's stretched horizontally, the major axis is this one right here. And as you see here, I already have the foci marked out. They would be somewhere around here. So let's talk about what they are. The foci is basically a point on an ellipse, 2 points on them, that if you were to take any point anywhere on the ellipse, it's going to get you the same. It will be the sum of those 2 lines going to each foci is going to be the same. So we'll call this D1 and D2. Okay. And then that's going to be the same here. If we have a point down here, so from here to this point, and then from here to that point, we'll call that D3 and D4. Okay, so what's interesting about that though is that if you have D1 plus D2, this is going to be equal to a constant. Okay, and that's going to be a constant for any ellipse. It's not going to be the same for every ellipse, but within that ellipse is always going to be the same. Same thing, D3 plus D4 will always equal that same constant. Okay, so now we can talk about how we can find the foci, because now since we have that basic knowledge, we can talk about something that's really neat, in fact. So like we have down here in this equation, our x minus 8 squared and y minus k squared over a squared and over b squared equals 1. We have our a, which is going to be here on the x-axis because it's under the x, and then our b, which is going to be with our y, because it's under the y, the b is under the y, and the a is under the x. So this number here is going to be the number that was squared. Half of the number that's going to be the whole length of the major axis. So on this side, we also have the major axis. So what's cool is that in one of the property of ellipses is that this c that we have written over with d1 plus d2 equals a constant within the ellipse. That c is actually equal to 2a. And that's very interesting. It's a very, very interesting property. Because of that, since we'll always have the a squared and the b squared given to us to be able to graph an ellipse, we can be able to take that to find where the foci are going to be. So, since we know that, like, we can take this point here, let me do this in a different color. I'll do it in black so it really stands out. So if we take this point here on the graph, we're going to take it right here from the top. That way we can make a triangle with it. Or we're going to take it directly to the first foci. And of course, it would go over to this foci as well. So I'll go ahead and draw that in. So this would also be this would be D4, this would be D5, and this would be D6 because it's another point, but it's still going to be equal to 2a. And since there's these two lines here, and this is coming from the top, we know that this is just equal to a, that it's going to be the equal distance from each other. And this is equal to b. So now, if we have the a squared here, we can take that the a squared, we can just take a, so square root it and get what a is there, and we can take that and b, but it's actually going to, well, we'll talk about that later, but right now we can go ahead and use the Pythagorean theorem. So we have a, so we can take a squared, let me get a different color out. So I'm going to move this so I can show you right under the ellipse. Okay, so now we can take what we know to be a, we can square that because we have the hypotenuse, and right now we need this length right here. Let me mark that out in black so we can know what we're looking for. We're looking for this length from the center of this ellipse out to the foci. So we can figure out how far the foci is from the ellipse so we can graph it. So we're going to take a and we're going to square it. And we're going to take minus b squared from it because we're going to do a mix of what we know as doing a squared plus b squared equals c squared. Because right here, we actually have this c squared part, even though we're representing it as a squared right now. So we're going to take that, we're going to subtract b squared from it. And that will give us what c squared would be. So this is going to be c squared. So if we take the square root of c squared, we're going to get how far over to the left and over to the right, unless it was a vertically stretched ellipse. And then we have to go up and down and change the y coordinate of it. So now let's go talk about how we could see this in the equation, because this is actually really easy to do with the equation, because as you can see, we already have the a squared, because a squared is this right here, which is also a right here, which we're going to have to square when we do the Pythagorean theorem, but it's already squared for us. And same thing with b. This is here is b, and in this over here, we had to square it anyways. They're already squared. So we can just look at a formula, and we can just take a squared minus b squared, and that's going to get us what we need. So in this case, we would take that and we would be able to take the center points. So we would take the negative h, we would take a squared minus b squared, the square root of that would be, we would add that to negative h right here, and then we would also subtract that to negative h. That way we get it's going both this way on the graph or this way on the ellipse to find this foci point, and then we take it this way to get this foci point. Okay, so now let's do a quick example. Okay, so we're going to have x minus 3 squared over, let's say, we'll do 16. Okay, and then we're going to have plus y minus 2 squared. We're going to have that as 9. Okay, so like we have up here, we can just take this a squared minus b squared. So we're going to do that. 16 minus 9. So what is that going to equal? That's going to equal 7. So we're going to have the square root of 7 is how far we go over. So let's just graph this real quick. I'll get a little graph going here. Okay, so we have okay. So we're going to go over 3, positive 3, and up 2. Because we got to do the opposite of what these says. Because like in my previous video I said, to remember this, you got to think about how couples and bad people won't do actually what they're saying when they're behind closed doors. So these gangsters here have to do the opposite of what they're doing, the opposite of what they're saying. So that's going to be our center there. And we know that the square root of 16 is 4. So it's stretched this way 4, and then this way 4. Then up 3, and then down 3. So we're going to, now we have our ellipse drawn here. If I can draw it. Okie doke. And we will put in our minor axis here, which because it's a smaller one, and our major axis. Okay, so that doesn't look the best, but good enough for what we need. So let's now get a different color here, and now we know that this, our foci, is going to be the square root of 7 over this way. So this length here is square root 7, and this length here is the square root of 7. So now we can kind of put that in a point. Let's say we want to, somebody's asking us for the exact coordinates of it. So we can just type in foci and then give them what they would like. They want to know how far forward this is. So we know the center is at 3. The center is at 3, 2. So since it's being stretched horizontally, that's the x direction. We're going to have to add and subtract it to the x. As you can see, that's what we had to do here. We had to go over square root 7 this way on the x plane, and then over this way on the x side. So what we can just do here is we can just put this in parentheses, and if you're lazy, you can put plus or minus square root 7 plus 3, 2. Or if you wanted to write square root 7 plus or minus 3, well, or the best way to write it would be 3 minus square root 7, 2, and 3 plus square root 7 comma 2. And this answer here should be square root 7 plus or minus. Okay, so let's do a little recap here. We know that the foci is the point that from any distance, any point at the edge of the ellipse is going to be the same two if you add it together. And that is equal to 2a. That constant is equal to 2a when you add them together. That's important because we can make a triangle here from the very top point that would be 1a. We can take our b and make a right triangle to be able to do that with. And then we can the simple formula for it is just a squared minus b squared equals the distance from the center up or down, or left or right it's going to be, depending on whether vertically or horizontally stretched. Okay, thank you for watching, and I'll see you on the next video.